All right, so today what I wanted to do is talk about section 7.1. It's called Basic Trig Identities. And there's three main trig identities, and actually you already know the first two. So the first type of identities are called reciprocal identities. And what the reciprocal identities are, remember we have the 6 trig functions. We have sine, cosine, and tangent. We have the other three, C, S, C. And what reciprocal means is that sine is 1 over the cosecant. Or you guys know at this point that cosecant's 1 over sine. You also know that secant's 1 over cosine, and that cotangent is 1 over the tangent. So cosine would be 1 over secant, and tangent would be 1 over the cotangent of theta. Just as a reminder, for the trig identities, we have SOHCAHTOA. In case you're a little bit rusty on what sides are what, so sine is opposite over hypotenuse, cosine's adjacent over hypotenuse, and tangent's opposite over adjacent. Most teachers write it like this, but I prefer that first way better. So a question that you could be asked from these first identities is you could be asked that if the secant of x is equal to 3/4, find the cosine of x. And this is a really easy problem. Right? Remember, the way we go from secant to cosine is we just take the reciprocal. So the reciprocal of 3/4 is just 4/3. Using the formula, so the answer is 4/3, but the reason why it's 4/3 is because cosine is 1 over the secant. So if we have 1 over 3/4, that's the same thing as keep, change, flip. And you'd see you get 4/3. We shouldn't have any issues with the reciprocal identities. The next set of identities are called the quotient identities. Just check something here. Quotient identities, we could draw, let me show you where they come from. Now we have our unit circle, which we talked about with quadrantal angles. And any point on that circle has an x and a y value. And remember we said that sine of this angle was y, cosine of this angle was x, and tangent, because the hypotenuse is 1, tangent would be y over x. Well, y was sine, so we could just plug that in right there. Cosine was x, so we could plug that right there. So really what we're saying is that tangent is equal to sine over cosine. And similarly, cotangent, if they're reciprocals, cotangent would just be cosine over sine. Those are your quotient identities. All right. So you might have a problem like this. If sine of theta is equal to 3/5 and the cosine of theta is equal to negative 4/5, find cotangent of theta. So the whole idea with this lesson is you want to try to figure out what formula has sine, cosine, and cotangent. Clearly that's this one right here. So if the cotangent of theta is equal to cosine over sine, then the cotangent of theta would equal negative 4/5 divided by 3/5. And we're going to keep, change, flip, and we'd get the answer as negative 4/3. Those are the kind of problems we would use the quotient identity for. Let me just highlight our formulas. All right, and now we're down to our third identity. The third identity is called the Pythagorean Identities. And we're going to use our same unit circle that we drew in the last properties. Remember, we have an X and a Y unit circle, so that's 1, right triangle. And you could see Pythagorean, well, Pythagorean theorem, if you remember, was a squared plus b squared equals c squared, right? The two legs squared. So for this triangle, we're going to say y squared plus x squared equals 1 squared, using the Pythagorean identity with this. Remember that y was the sine of theta, and x was the cosine of theta. So if we just plug those in, y is sine squared, x is cosine squared. 1 squared is 1. That gives us a whole new identity. And just so you know, sine squared of theta just means sine of theta squared. It's just notation. So you could have also written this sine of theta squared, meaning times itself, plus cosine of theta squared equals 1. All right. Now, because we have one kind of identity, there's actually 3 here. The first identity is this one. And to get our second identity, what we're going to do is take those values and we're going to divide everything by sine squared of theta. For example, sine squared of theta divided by sine squared of theta is 1. Cosine squared of theta divided by sine squared of theta, well, this was a quotient identity, that's cotangent squared of theta. And 1 divided by sine squared of theta is cosecant squared of theta. That gives us another identity. And then we could get one more by dividing everything by cosine squared of theta. So sine squared divided by cosine squared of theta is tangent squared of theta. Cosine squared of theta divided by cosine squared of theta is 1. And 1 divided by the cosine squared of theta is secant squared of theta. So those are your 3 identities. Now most people memorize them, but if you were to stop me in the hall and say, hey, Mr. O, quick, 1 plus cotangent squared of theta is equal to what? I'm not going to know what it is. I'm going to, take sine squared plus cosine squared is 1, and I'm going to have to divide that by sine squared and cosine squared to get these other 2 formulas. But those are your Pythagorean identities. So let's do an example with these. Example would look like if cosine of A is equal to 3/5. Find cosecant of A. Now the problems that we're going to be seeing, I'm not going to tell you which formulas to use. So you have to look at all your formulas and think about, which formulas include all of these trig functions. Well, if we know cosine is 3/5, I could easily make this into secant. And if we want to find cosecant, well, I know that we could easily use sine instead. So which formula uses any of these four? So do you see a formula with cosine and cosecant, or a formula with cosine and sine, or a formula with secant and sine? So it's going to take a little while to figure it out. And eventually, I see this formula. This formula has cosecant, but I can't convert cotangent to cosine. I'm not going to use that one. And the third one, well, I could use secant. I could plug that in right there, but I don't want to use the third one because that has a tangent in it. This first formula, sine squared plus cosine squared is equal to 1, well, I could use that because if I know that cosine of A is 3/5, I could put that right here. And we want to find cosecant. So the game plan for this is we'll find sine, and then we'll convert that to cosecant. 3/5 squared is 9/25. 1 minus 9/25 is 16/25. And if we go to take the square root, because that's being squared, we would get that the sine of A is equal to plus or minus 4/5. Remember, the absolute value of something squared turns into, square root of something squared turns into absolute value. And then we could get rid of absolute value by writing plus or minus. But the question said find cosecant, right? So we found sine, and we could easily convert this to cosecant by taking the reciprocal. So the cosecant of A would be plus or minus 5/4. That's the lesson today. What I would like you to please do for homework is on page 362. Please try numbers 20 to 32 even. Thank you very much. Have a nice day.